limits. Now we're going to go into derivatives. So basically, it's really helpful to know what a derivative is. So we talked about secant lines, I think, and then we definitely talked about tangent lines. So a tangent line is a straight line that touches the original function that you're given at only one point. So kind of something like this, or actually something like this. So at any point you can draw a tangent line. It's just something that touches the function at only one point. So it's basically brushing right up against it. So the derivative is the slope of any of these functions, right? So this one's going to obviously be very negative because it's very steep. This one's going to be 0, okay, because it's horizontal. This one's going to be a little bit negative because it's a little bit down. And this one's going to be positive because it's up. So what can you tell from this, like the slopes of all these points? Well, I just talked about it. So you can tell where it's increasing or decreasing, because if it's very negative, you know it's very steeply decreasing. You can tell where the function is flat. So if it's 0, it means the function is flat. You can tell where it's increasing, or how much it's increasing or decreasing by, because if it's only a little bit up, that means it's only a little bit increasing, and if it's a lot down, it's very negative, so very decreasing. So all of this thing, or all the things that the slope can tell you, or everything that the derivative can tell you, is something that you can tell from the slope, because it immediately deals with the slope of the tangent line. So we're going to talk about some of this stuff conceptually. There's another video where we talk about procedures on how to do it. That one's called Applications of Derivatives. So approaching the topic of increasing and decreasing from a more conceptual standpoint. So looking at these two graphs, I know you can kind of see the answers, but looking at these two graphs, what is fundamentally different between these two? This one goes up, this one goes down. That's the biggest difference. So this one going up means it's increasing. This one going down means it's decreasing. Same as like the logical definition of these two words. So how did you tell it's increasing? Because the slope is going up. The values of the function are going up, the slope is going up, any of those. This one's decreasing because the slope is pointed down. It's as simple as that. So anytime you're looking for something that's increasing or decreasing, you're looking at the slope and whether it's going up or down, whether it's positive or negative. So how do you find that easiest? So you can actually tell where it's positive or negative by finding where it's 0 and then looking on the outside of that. So imagine this kind of function, right? You find where it's 0, and what is the definition of a function or a slope that is 0? It means horizontal. So you're going to find where the slope of the tangent line is 0. And that's where it's horizontal. So that's going to be at the top of a peak, or at the bottom of a peak, or at a little bit of a switch. So we'll talk about that in a second. So you can find where it's positive or negative by finding where it's 0 and looking on either side of that, right? Because it can't be 0 all the way across, or it would be a straight line. So to do that, you're going to use the number line technique. So you can look in your notes for that, or we talk about it in the Applications of Derivatives video. So you can look at either of those two resources, but you basically want to use the number line technique. So another thing you can do is talk about maximums and minimums. So if we look back at this graph, what we just talked about, you found where it was 0, right? And we talked about how it'll be increasing or decreasing on either side of that. But if you look at that, this little shape here has a maximum point. So that's what we kind of want to look at. You want to find where the tangent line is and what it's doing on either side of it. And if it's going from increasing to decreasing, you know that at some point there's a maximum value, because it'll look like a little hump. And if it's going from decreasing to increasing, you want to find where, or you're going to find a minimum, because it's going to look like a bowl. So again, these both had horizontal tangent lines that had a slope of 0, and you looked at the behavior on either side of it. So another thing that you want to kind of know a little bit more intuitively or conceptually is what you plug in where and when you want to plug that in. So anytime you want to know any kind of information about the slope of the original function, so where it's increasing, where it's 0, where it's decreasing, anything like that, or where it asks for the critical points, you want to plug that into the derivative of the function, the actual first derivative. Anytime you want to find information about the value of the function itself, so the y values of the critical points, or the maximum mins, or the maximum values or minimum values, whether they're local or absolute, you want to actually know the value of the function. So what is the maximum value of the function? That can only be told from the original. So again, either, I think my video might have cut out, but I'll just repeat that a little bit. So information about the slope is going to be from the derivative. Anytime you want to know where the derivative is, where the actual point you're talking about is on the original function, you're going to talk about plugging it into the original function. So you'll have an x value and plug it into the original. So then going into